Hello students, this video is to help you group number 2 on function families, domain, and range. Please make sure you're filling out this worksheet with me as we go. The first function family we will look at is the square root function families. So you'll know it's a square root because the equation will have a square root symbol in it. This is your most basic function. It's called a parent function, and it pretty much tells you what the shape of these functions are. They all have this same kind of shape. It has a distinct starting point, so this one starts right here at 0, and then it kind of curves like this, and it grows, and it grows, and it just goes forever in this direction. Now, what happens if we put a 2/3 in the front? Well, this 2/3 is like a slope. So because 2/3 is like a small fraction, that means it's going to grow at a smaller pace. So the curve is not as big. It's like a shallower curve. It's still growing. It's just not that fast of a growth. It's a slow growth. And then this +1 at the end, anytime you see a number at the end of a function like this, notice it's not inside the square root with the x, it's outside. What that does is it moves your function up, because it's positive, 1. So this function starts up here at the +1, whereas the other function started at the 0. So this one moved up 1. Our next function, a square root function, has a -2 at the end. So that means it's like it was shifted down 2. Down because it's negative. So look at where it starts. It starts down here at the -2, whereas the other one started at the +1. Now this shape, instead of growing upwards, it's going downwards. Why? Because of the negative in front. If there's a negative in front, it's going to reflect your function and flip it upside down. The 3 is kind of like the slope. That means it's going to grow much faster. It's decreasing at a faster rate. All right, so if we look at all of these functions together, we can talk about their domain, which is all the x values. In other words, how far to the left do they go and how far to the right do they go? That's what domain is asking you. It's asking you about the x direction, left and right. And then the range is how far up and down does the function go, because it's dealing with the y values. So let's answer these questions. The domain of square root function depends on where it starts. So x is greater than or equal to the lowest value. So if you look at the x-axis, all of these actually start at the 0. If you look at the x-axis, none of them start over here on the 1 or the 2 or the 3. They all started at the 0. There could be examples where they start in different places, but I just happen to pick them where they all start at 0. So you would say that the domain is all real numbers greater than or equal to 0. So you put a 0 right there. You could also put that x is less than or equal to the highest value if this was turned around going the other way, which I'm not sure what happened in a square root function actually. I'll have to look into that with more detail. But what you need to know is that they go forever to the right or they go forever to the left. In these examples, they all go forever to the right. They do not go forever to the left. They actually stopped right here. The range of square root function depends on where it starts as well. These functions do not go forever up and down. They have a limit. So since range has to do with the y values, you're going to say y is greater than or equal to, and then you give me the lowest value. So for this green line, you would say y can be anything that's greater than or equal to 0. For the blue line, you would say y can be anything that's greater than or equal to 1. And for this red line, you have to tell me that y is everything less than, because it's going downwards. So you would say y is less than or equal to -2, because it started right here at the -2. All right, so these go forever up, or like these two go forever up, or they'll go forever down, only in one direction. Let's move on to the exponential function family. They look something like this. They grow slowly, and then they grow faster and faster. They get steeper and steeper. This is what exponential growth looks like. You start off slow, and then you speed up as you move from left to right. This line is called an asymptote. That means that the function gets really close to it, but it never touches it. So the asymptote here is y equal to 0. It's approaching the 0 value of y. If your multiplier, that's what I call it, the base here, if it's a fraction, if it's less than 1, then it's actually exponential decay. That means it starts off fast and then it slows down. The asymptote is still 0. It's approaching this x-axis, which is where y equals 0. What happens if you throw a negative in front? Well, if you throw a negative in front, that flips it. It reflects your function. So it's still approaching this x-axis. It's still approaching where y equals 0. But this time it's flipped upside down. And it has a negative exponential growth. Exponential growth, yeah. If we look at all of these together, this is what they look like. And if we were to talk about their domain and their range, this is what we would say. The domain of all exponential functions is all real numbers. Why? Because if you look at the domain, which is the x's, they go forever to the left. They're all approaching this negative infinity over here. And they all go forever to the right as well. They all go to this direction in the right. The blue one is going up and to the right. This red one is kind of leveling off at the right. And this green one is going down and to the right. But they're all going to the right. So that's why we say all real numbers. The range of these exponential functions depends on the asymptote. So you're going to say that the y is greater than the lowest value. So for example, this red one and this blue one, we would say y can be anything that is greater than 0. The lowest value is 0. Y can be anything above that, but y will never be 0. It approaches 0, but it supposedly never touches the 0. It will never touch this x-axis. It looks like it touches, but it doesn't. If you zoom in, it will not touch. So what about this green one down here? It's very similar. You would say that y can be anything that's less than this 0. So y is less than 0. All right, that's it for this video. Thank you.